today's video, you are going to learn how to find all solutions of polynomial functions. Everything that we have done up until this point has been a real solution when we talked about polynomials. When we did quadratics in Unit 1, we found all the solutions of quadratics, both real and complex, so real and imaginary. But so far with polynomials, we've only talked about the real solutions. That is going to change today. Very exciting. Today we are learning the fundamental theorem of algebra. A polynomial of degree n has exactly n roots in the set of complex numbers. So whatever the degree of the polynomial is, that is how many answers that you will have, how many solutions. Remember, the solutions are the same things as roots. Roots are the same things as zeros. Zeros are the same thing as x-intercepts. So when we're talking about roots and zeros and solutions, we're always talking about those x-intercepts. So remember that not all zeros will be real numbers. That's what we've had so far in this unit, but imaginary numbers do exist. We talked about those back in Unit 1. When you have a complex root, so an answer that is imaginary, the complex roots always exist in conjugate pairs. I want you to think about it this way. Imaginary numbers always have an imaginary friend. So imaginary solutions always come in pairs. So if you have a solution of the form a plus bi, then that means a minus bi is also a zero of the function. Remember, we learned about the complex conjugates back in Unit 1, where if you have a plus bi, the conjugate was a minus bi when you change that middle sign. You might find this helpful to go back and start reviewing some of that Unit 1 material. You'll want to do that anyway to start preparing for our test that we're going to have at the end of the semester. That's going to cover everything. So let's look at these. If we have a polynomial of degree 1, only one thing can happen. If it is of degree 1, then we can only have one real root. We will never have an imaginary answer when it is linear. Remember, degree of 1 is linear. And that is because imaginary solutions come in pairs, and if we only have one solution, that solution can't come in a pair. So that might look something like this, where it crosses the x-axis only one time. If it is of degree 2, remember degree 2 is when it is quadratic. Two things can happen here. You can have two real solutions or two real roots, and that will happen when you have a parabola like this, where it crosses your x-axis twice. But you could also have two imaginary roots. And that's going to happen when your parabola does not cross your x-axis. So that could be something like this. This parabola never touches this x-axis, and it will never. So the two solutions to this one are imaginary. They're not there. If we have a degree of 3, again, two things can happen. Remember, degree 3 is cubic. You could have all three real solutions. And that's what you've had so far in this unit. A graph of a cubic that has three solutions might look something like this, where it crosses your x-axis 3 times. Another thing could happen. You could have one real solution, so one real root, and two imaginary roots. You could not have it the other way around. You could not have two real and one imaginary, because remember, your imaginary numbers always come in pairs. Your imaginary number needs an imaginary friend. So your imaginary solutions are always going to be in pairs. They're always going to be even numbers every single time. So in a cubic function that has one real root and two imaginary roots might look something like this, where it is only crossing your x-axis once, and then your other two roots are imaginary. And then if we are of degree 4, this is quartic. And 3 different things could happen here. The first thing that could happen is that you could have 4 real roots. So 4 real solutions. And that's what you've seen so far when we've done quartic functions. So that might look something like this, where you cross your x-axis 1, 2, 3, 4 times. You could have a combination. You could have 2 real roots and 2 imaginary. And that might look something like this, where it only crosses your x-axis twice. And then the third thing that could happen is that you could have 4 imaginary solutions. So 4 imaginary roots. And that would be when you split them up into 2 pairs of 2, right? So that might look something like this, where it never crosses the x-axis, nor will it ever. On the next page, it says, state the number of roots, the possible number of real solutions, and the possible number of imaginary roots for each function. So let's see. We're using the fundamental theorem of algebra. When I look at this problem, my highest degree is 4. So I am going to have 4 roots. If I have 4 roots, then I could have 4 that are real. And if I have 4 that are real, then that means that I would have 0 that are imaginary. Could I have 1 that is real? Or sorry, let's go the other way. Could I have 3 that are real? Well, if I have 3 real and I want to get to 4, then I would have to have 1 imaginary. Imaginary numbers have to come in pairs, so that won't work. I could have 2 real solutions. If I had 2 real solutions, then that would mean I would have 2 imaginary solutions. I could not have 1 real solution because then I would have to have 3 imaginary, and 3 is not a pair, right? Everything has to come in pairs. One of my imaginary numbers will not have an imaginary friend, so that would not work. I could have 0 real solutions and 4 imaginary solutions. Those are all the possible scenarios that could happen if I were to solve this problem. Let's do the same thing with example 2. My highest degree is 5, so that means that I'm going to have 5 roots. I could have all 5 of those roots be real. If all 5 are real, then 0 will be imaginary. If I try to have 4 real roots, well, that won't work because I can't have an odd number for my imaginary numbers, because my imaginary numbers always have to have an imaginary friend. I could have 3 real solutions, and then I would have 2 imaginary solutions. I couldn't do 2 and 3 because that would leave me with an extra imaginary number without an imaginary friend. I could have 1 real solution and 4 imaginary solutions. Those are the possibilities for if I were to solve example 2. Let's look at example 3. Example 3 says to state the possible rational zeros. So that's the first thing that they're looking for the function, and then find all the zeros. So that's the second thing they're looking for. Write zeros in radical form if applicable. So this means no decimals. We always want exact answers. So let's see what that looks like. To find my possible rational zeros, this is when you have to do constant divided by leading. My constant is 3. The factors of 3 are 1 and 3. My leading coefficient is 1. The factors of 1 are 1. So my possible rational zeros are plus or minus 1 and plus or minus 3. And again, to do that, that's what I'm doing, constant divided by leading. This was the first thing that they were looking for. From here, we want to find all of the zeros. Well, earlier in this unit, we learned that we can find zeros by looking at our graph and our table of values. So let's pull up Desmos. I know that I am going to have 3 solutions. Maybe I can find all 3 using Desmos. So I'm going to go to desmos.com/calculator and I'm going to type in our equation. So I have x raised to the 3rd power minus 6x squared plus 8x plus 3. And so here, that's a decimal. We don't want decimals. 3 works, and that's a decimal. That's not going to work. What you can do if you're not sure what's going to work and what's not going to work is go to your settings and click on your table and put your possible rational zeros here. So our possible rational zeros are 1, -1, +3, and -3. And when I do that, I can see the only 0 that I get is the 3. So this is the only one that I can use. So if that is the only 0 that I can use, let's go ahead and write that 0 down. So we have x equals 3 from our possible rational zeros, and we got this from the calculator. We know there are going to be 3 solutions. And right now we only have 1 of them. To find the other ones, let's do synthetic division. So if 3 is a 0, then my coefficients are 1, -6, 8, and 3. I'm going to bring down my leading coefficient. And because this is a 0, I know that I'm going to get 0 right here for my remainder. 3 times 1 is 3. That's going to give me -3. 3 times -3 is -9. That gives me -1. 3 times -1 is -3. That is going to give me 0. So if 3 is a 0, then that means that x minus 3 is a factor. We started with x cubed, so this is x squared, x to the 1st, and x to the 0th power. So this factor is 1x squared minus 3x minus 1. We always want to factor completely. X minus 3 is a linear factor. Let's try and factor this factor right here. So if I were to do that using the area model, I would have x squared and -1. So here I'm looking for factors of -1 that add to -3. There are no such factors. We cannot factor this. Lucky for us, we learned another method in Unit 1 of how we can continue to solve this polynomial. Remember that the quadratic formula always works. I now am dealing with a quadratic function that needs to be solved. So let's use the quadratic formula. So to remember, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to have x equals negative, and then negative 3, plus or minus the square root of negative 3 squared minus 4 times 1 times negative 1. Do not be lazy. You write your parentheses here. Most mistakes from the quadratic formula happen because you forget to put your numbers in parentheses, and then when you go ahead and square this, you forget that you're not squaring the negative unless it's in parentheses. So do yourself a favor, write out all the parentheses. That way when you go to plug this into your calculator, you will get the correct answer. This is going to be divided by 2 times 1. So a negative times a negative is a positive. So it's going to be positive 3 plus or minus. And next I'm going to calculate my discriminant. Remember, your discriminant is what is underneath the square root symbol. And when you do that, you get 13. 2 times 1 is 2. You always want to try to simplify as much as possible. The square root of 13 is already simplified. I know that because 13 is a prime number, so I can't simplify this. If you could do birthday cake with it, you would. So you would simplify this as much as possible. 3 and the square root of 13 are not like terms, and there's nothing to reduce here. So I have 2 solutions from the quadratic formula, and I have 1 solution from the calculator. That is all 3 of my solutions. So the second thing that they wanted were the solutions. I have I have 3 plus the square root of 13 divided by 2, and 3 minus the square root of 13 divided by 2. These are my 3 solutions. Again, the 3 came from the calculator, and then these 2 came from the quadratic formula. Let's look at example 4. On example 4, it says state the number of solutions, the possible types of solutions, the possible rational zeros, and find all the zeros. So they're asking us to do 4 things. State the number of solutions, the possible types of solutions, the possible rational zeros, which are the PRZs, and then find all the zeros. So 4 different things that they're looking for here. So how many solutions will there be? Well, if I look at my equation, my highest degree is 3, so this will have 3 solutions because the highest degree is 3. What are the possible solution types? Well, I could have 3 real zeros and no imaginary. And there's only one other type of possibility. I could also have 1 real zero and 2 imaginary. Remember that your imaginary numbers always have to come in pairs. Your imaginary numbers always need an imaginary friend. What are your possible rational zeros? Well, those are our PRZs. To do that, we do constant divided by leading. Here, my constant is 100. The factors of 100 are 1 times 100, 2 times 50, 4 times 25, 5 times 10, 5 times 20, and 10 times 10. My leading coefficient is 1. So my possible rational zeros, remember it's always your constant divided by your leading. So that's going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, plus or minus 25, plus or minus 50, and plus or minus 100. So those are my possible rational zeros. Step 4. Use Desmos to determine which PRZs are actually zeros. If we are lucky, 3 of these are zeros, and then we have our answers and we're done. If we're not so lucky, we'll find a couple and we'll need to solve for the rest. So let's go to Desmos. So I'm going to type in my equation here. So I have x cubed plus 9x squared plus 40x plus 100. Now, I'm not going to waste time looking at Desmos because I don't know what's going on with everything there. What I'm going to do is I'm going to look at my table. And I'm going to put my possible rational zeros in my table. And I'm just going to keep adding them until I find a zero. So let's see, I have 1 and -1, 2 and -2, 4 and -4, 5 and -5. So -5 works. Let's see if we have any more. 10 and -10. 20 and -20. 25 and -25. 50 and -50. 100 and -100. So out of all of our possible rational zeros, only -5 is an actual zero. That's the only place where we see it cross too. Even if I keep scrolling out forever, I'm really only seeing it cross in that one spot. And so it looks like that's the only real zero. So if I go back to our notes, we know that one of our zeros is x equals -5. We found one real solution, which means the rest are imaginary. Let's write that down. We found one real solution, which means the rest are imaginary. We knew that we were going to have 3 solutions. One of them is real, so the remaining 2 solutions are going to be imaginary. To figure out those solutions, we're going to keep doing what we've been learning this entire unit. We're going to use synthetic division to help us factor. So, if -5 is a 0, my coefficients are 1, 9, 40, and 100. -5 times 1 is -5. That gives me 4. -5 times 4 is -20. That gives me +20. -5 times 20 is -100. That gives me 0. So right now I have that -5 is a 0. So that means x plus 5 is the factor. We started with x cubed. So this is x squared, x to the first, and x to the 0th power. So this factor is x squared plus 4x plus 20. If we can factor this, that will make our life easy, and we can try and factor that and solve. If it's not factorable, because it is a trinomial, I would use the quadratic formula. So are there factors of 20 that add to 4? No. So this is not factorable, and so we're going to use the quadratic formula. So A will be 1, B will be 4, and C will be 20. So I'll have x equals -b plus or minus the square root of b squared minus 4ac all over 2 times a. So I'm going to have x equals negative 4 plus or minus the square root of. And from here, you want to calculate your discriminant. When I do that, I get negative 64 all over 2. Now you always want to simplify as much as possible. The square root of negative 64, we can think about that as the square root of positive 64 times the square root of negative 1. What's the square root of 64? 8. What's the square root of negative 1? I. So we have x equals negative 4 plus or minus 8i over 2. We can reduce this. Negative 4 divided by 2 is negative 2. 8i divided by 2 is 4i. So I have my 3 solutions. My first solution, we got that from the calculator. Negative 5. My second solution is negative 2 plus 4i. And my third solution is negative 2 minus 4i. Again, this one came from Desmos, and these two came from the quadratic formula right here. Let's look at example 5. It says state the number of solutions, the possible types of solutions, the possible rational zeros, and find all zeros. So the same exact 4 things that they wanted us to find on the previous page. So my highest exponent is 3, so I will have 3 solutions. Oops, let's write that in a color pen. There we go. What are the possible solution types? Well, we could have 3 real zeros and no imaginary. Or we could have 1 real zero and 2 imaginary. These are the only 2 possibilities. Remember that your imaginary solutions must come in pairs. What are our possible rational zeros? Well, that is constant divided by leading. Here my constant is 15. Factors of 15 are 1 and 15 and 3 and 5. My leading coefficient is 1. So my possible rational zeros are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. From here, we're going to use Desmos to determine which possible rational zeros are actually zeros. So I'm going to go to Desmos. Let's delete this one. And if ever your graph gets like really too much zoomed out or zoomed in, you can just refresh your page to reset it. So our equation is x cubed minus 5x squared plus 3x minus 15. So let's go to our table and plug in our possible rational zeros. So I have positive 1, negative 1, positive 3, negative 3, positive 5, negative 5, and then positive 15 and negative 15. So out of our possible rational zeros, we found one of them. It's this 0 right here. It's 5. So we only got 1 0 from our calculator. Since we found one real solution and we know that we are going to have 3 of them, then we know that the other 2 must be imaginary, because if they were all 3 real, then they would have come from this right here, and then we didn't find any other ones, so this is the only one we got, so the other 2 have to be imaginary. So we found one real solution. So the rest are imaginary. So now we're going to use synthetic division to help us factor to solve this further. So if 5 is a 0, I can use that here. My coefficients are 1, -5, 3, and -15. 5 times 1 is 5. That's going to give me 0. 5 times 0 is 0. That's going to give me 3. 5 times 3 is 15, and that gives me 0. So I have, if 5 is a 0, then x minus 5 is a factor. I started with x cubed, so this is x squared, x to the first, and x to the 0th power. So here that's going to be x squared plus 3. Here, this is a quadratic. It is only a binomial. And so because it's a binomial, we wouldn't necessarily use a box method here. The only way that you can factor a binomial is if you use a difference of squares. X is being squared, but 3 is not a perfect square. So I can't use a difference of squares to factor this. Also, it's not a difference, it's a sum. When this happens, you can solve by taking square roots. So, if I have x squared plus 3 equals 0, I can solve this by subtracting 3 on both sides. So I'm going to have x squared equals -3. To undo a square, I'm going to take the square root and get x squared, I'm going to get x equals plus or minus. If I have the square root of -3, I can break that up into the square root of -1 times the square root of 3. The square root of -1 is I, and then I cannot reduce the square root of 3. Now I have all 3 of my solutions. The first solution was 5 from my graphing calculator, so from Desmos. And then I got positive I square root of 3 and negative I square root of 3. Those are my 3 solutions. If we look at example 6, it says find the possible rational zeros and then find all zeros of the function. So to find my possible rational zeros, I need my constant divided by leading. When I look at this equation, I do not have a constant. So that means that I have a GCF that I need to factor out first. Here, my GCF is x. So I'm going to have f of x equals x times x cubed plus 11x squared minus 25x plus 13. Now I can do my constant divided by my leading. Here, my constant is 13. Factors of 13 are 1 and 3. My leading coefficient is 1. Factors of 1 are 1. So my possible rational zeros are plus or minus 1 and plus or minus 13. Let's go ahead and go to Desmos and see which of these are actually zeros. So if I go to Desmos, I'm going to go ahead and close that out. And I'm going to have x to the 4th plus 11x cubed minus 25x squared plus 13x. And when I go to my table, I'm going to type in my zeros. So I have positive 1, negative 1, positive 13, and negative 13. Here I can see I have 2 zeros, positive 1 and negative 13. When I look at my graph, here I can see that I have 0, 1, And then if I scroll out, 13. We know that we're going to have 4 zeros. Right now, we have 3 of them. Let's go back to our notes so I can show you the 3 that we have. Right now, if x is a factor, then that means that 0 is a solution. This is from the GCF. We also found that 1 and negative 13 were solutions from the table. That's 3 real solutions. I am going to have 4 solutions. If 3 of them are real, then that means 4 are real, because we can't have 3 real solutions and 1 imaginary, because remember that our imaginary numbers always come in pairs. If we look at our graph again, you'll notice that one of our zeros has a multiplicity. At 1, we touch and turn around here. So because we have a multiplicity at 1, now we have all 4 of our solutions. So our zeros are 0 from our GCF, 1 with a multiplicity of 2, so that's 2 solutions, and then negative 13. So again, here I have 1 plus 2 is 3 plus 1 is 4 real solutions. We found all 4 using the calculator. If we look at example 7, it says find the possible rational zeros and find all zeros of the function. So, first thing that I'm going to do is find my possible rational zeros. My possible rational zeros are when we do constant divided by leading. Here, my constant is 14. Those factors are 1 and 14 and 2 and 7. My leading coefficient is 1. So my possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. Now let's check for the zeros and Desmos. So I'm going to go ahead and open up Desmos. And here I'm going to type in my function, which is x to the 4th plus 9x squared plus 14. And when I do that, if I scroll out, you'll notice that my function is never crossing my x-axis, which means that I'm not going to have any real zeros, and all of my zeros are going to be imaginary. If you're not sure, go ahead and plug in all of your possible rational zeros into your table and check. So we have positive 1, negative 1, positive 2, negative 2, positive 7 and negative 7, positive 14 and negative 14. None of these are zeros. So that means that all of our solutions are imaginary. So let's write that down. The graph of this function does not cross the x-axis. That means that all solutions are imaginary. So when this happens, the first thing that you're going to try to do is you want to try and factor. So I'm going to use the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. Here we're looking for factors of 14 that add to 9. Those two numbers are 7 and 2. 7 plus 2 is 9. 7 times 2 is 14. So the greatest common factor in my top row, oops, I forgot one thing. My middle term is x squared, so both of these are going to be x squared. The greatest common factor in my top row is x squared. The greatest common factor in my bottom row is 2. The greatest common factor of the left side is x squared, and the greatest common factor of the right side is 7. So my factors are x squared plus 2 times x squared plus 7. From here, we're going to set each factor equal to 0 and solve, just like how we did back in Unit 1. So I'm going to have x squared plus 2 equals 0 and x squared plus 7 equals 0. To solve this first equation, I'm going to subtract 2 on both sides and get x squared equals negative 2. To undo the square, I'll take the square root and get x equals plus or minus I square root of 2. For my second equation, to undo addition, I'll do subtraction and get x squared equals negative 7. To undo the square, I'll take the square root and get x equals plus or minus I square root of 7. So I have my 4 solutions. My 4 solutions are positive I square root of 2, negative I square root of 2, positive I square root of 7, and negative I square root of 7. On this last page is just a summary of all the different things that could happen. So if you have a cubic, that means that you're going to have 3 solutions. When you get 3 solutions, those 3 solutions could be 3 real and 0 imaginary, or 1 real and 2 imaginary. When you get 3 real and no imaginary, you could have 3 rational numbers, 1 rational and 2 irrational. And then when you have 1 real and 2 imaginary, your solution types will be 1 rational number and 2 imaginary numbers. When you have a quartic function, you will have 4 solutions. You could have 4 real and 0 imaginary. When this happens, you'll either have 4 rational solutions, 2 rational and 2 irrational solutions, or all 4 irrational. You could also have 2 real and 2 imaginary, which would give you 2 rational numbers and 2 imaginary numbers, or 2 irrational numbers and 2 imaginary numbers. Or you could have 0 real and 4 imaginary, and when that happens, all 4 of your solutions will be imaginary. Down here, if you ever forget the steps of what to do, this is how you should solve if you have a cubic, and this is how you should solve if you have a quartic. I would definitely use this page as reference as you are studying and preparing for your Unit 3 test. Definitely have this out while you are working through your practice problems. Remember, the key for studying for mathematics is by working out practice problems for yourself. So you definitely want to make sure that you've completed all of the practice problems that have been assigned. If you need more practice, go in the Go Further folders and practice those things. And then you could also come in for tutoring and do what you need to do to be successful on the Unit 3 test.